Have you ever noticed how a tidy room naturally gets messy, or how a hot cup of coffee always cools down? This isn't just bad luck. It's a fundamental law of the universe at work, and it's called entropy. Today, we're diving into the theory of entropicity, a concept that explains why chaos seems to be the default setting of everything around us. So, what exactly is entropy? In simple terms, it's a measure of disorder or randomness. The second law of thermodynamics states that in an isolated system, the total entropy can only increase over time. Think of it like a one-way street. You can easily scramble an egg, but you can't unscramble it. The universe is constantly moving from a state of order to a state of disorder. Let's use a simple analogy. Imagine you have a box with a divider in the middle. On one side, you have red gas molecules, and on the other, blue gas molecules. This is a highly ordered state. Now, what happens when you remove the divider? The red and blue molecules will start to mix randomly until they evenly distributed throughout the entire box. This mixed up state is much more disordered and therefore has higher entropy. The chances of them spontaneously separating back into red and blue sides are practically zero. This is entropy in action. This principle isn't just for gas molecules. It applies to everything. Stars burn out, buildings crumble, and even information gets lost or corrupted over time. It's the reason why your headphones always end up in a tangled mess in your pocket. There are simply far more ways for things to be disordered than for them to be ordered. A tangled state is a high entropy state. A neatly coiled state is a low entropy one. The universe just naturally falls into the state with the most possibilities, which is almost always the messy one. But if the universe is always moving towards maximum chaos, how does life exist? Life is a stunning example of local order. Organisms, from a single cell to a complex human being, are incredibly organized. Low entropy systems. How is this possible? The key is that living things are not isolated systems. We maintain our order by consuming energy from our surroundings like the food we eat or the sunlight plants use for photosynthesis, and in the process, we release heat and waste, increasing the total entropy of the universe around us. So, we create a small pocket of order for ourselves, but at the cost of creating even more disorder in the larger system. We're basically fighting a constant uphill battle against entropy just to stay alive. The theory of entropicity even has implications for the ultimate fate of the universe. One popular hypothesis is the heat death of the universe. In this scenario, entropy will eventually reach its maximum possible value. All energy will be evenly distributed, and there will be no temperature differences left to drive any processes. Stars will have all burned out. Matter will have decayed, and the cosmos will become a cold, dark, and uniform soup. Nothing will happen forever. It's a pretty bleak thought, but it's a direct consequence of this relentless march towards disorder. So, the next time your room gets messy or your hot drink gets cold, remember it's not just you. You're witnessing a fundamental principle of the cosmos. From a simple box of gas to the grand scale of the universe, entropy dictates the direction of time and the flow of everything. It's the ultimate cosmic rule that everything must eventually fall apart. It's a powerful reminder of the temporary and precious nature of order and complexity in a universe that overwhelmingly favors chaos. Thanks so much for watching. If this blew your mind, be sure to hit that like button and subscribe for more deep dives into the mysteries of science. See you next time.